Welcome to the deep dive. We've got some interesting source material today. Feels like it's taking us somewhere unexpected.
Yeah, it definitely bridges a couple of different worlds. We're looking at agriculture, but also, well, mathematics.
Right. Specifically connecting calculus, I see here, integration with farming.
Exactly. The source material digs into how integration can be used to track something pretty specific in that setting.
Okay, I'm intrigued. Integration,
Mm.
area under the curve, that kind of thing. How did that connect to, say, a dairy farm? I'm picturing, well, fields, not formulas.
And that's the interesting bit, isn't it? The core idea in the source is using mathematical integration as a specific way to track the volume of lactation in dairy animals.
The volume of lactation. Okay, and it gets more specific, doesn't it? It mentions dairy animals fed with alfalfa.
That's right. It pins it right down to that context: alfalfa grown on agricultural land, fed to the animals.
So it's that whole cycle.
Yeah.
Land, feed, animal, output. And math is being used to measure part of that output.
Precisely. The source links the mathematical tool to that very specific agricultural chain.
So our mission for this deep dive is to unpack how this source suggests using integration. Like, what's the specific approach or formulation it proposes for measuring lactation volume, specifically in this alfalfa-fed scenario?
Exactly. How does an abstract concept like integration actually get applied to quantify a very real biological process that's tied directly to farming inputs? The source really scopes it to tracking that volume in dairy animals fed alfalfa.
Okay. But, the obvious question comes up, why integration? Why not just measure the milk, weigh it or something?
That's a fair point, and the source sort of implicitly gets at that. You can measure the total at certain times, like morning and evening milking.
Right.
But the thing is, milk production isn't constant. The actual rate it's produced changes throughout the day.
Ah, okay. Influenced by things like feeding times,
Mm.
maybe how they digest the alfalfa.
Exactly. Feeding schedules, the animal's own body rhythms, it all affects the rate of flow. So just measuring twice a day doesn't give you the complete picture of the total volume produced continuously, especially if the rate is changing a lot.
I see. So integration is the tool for finding the total amount when you know the rate it's accumulating, even if that rate is bouncing around.
You've got it. That's the power of integration. The source explores how you'd need to model that fluctuating rate of milk production first.
So you need some kind of mathematical description. Is that what they mean by formulation?
Yes, exactly. The formulation would be the specific mathematical function that describes the rate of milk flow over time. Maybe it includes variables related to the alfalfa feed, nutrient uptake, things like that.
Okay, so the formulation is like the recipe, the equation that captures how fast the milk is being produced at any given moment.
That's a good way to think about it. The challenge, as the source points out, is figuring out the right mathematical description, the right formulation that accurately matches the real biological process, especially considering that alfalfa diet.
It doesn't give the exact equation then.
No, the source points more to the method. It identifies integration as the essential mathematical step after you've established that rate function, that formulation.
So it's about getting beyond simple snapshots to a more dynamic model, summing up the production based on its changing rate and linking it back to specific inputs like the alfalfa.
Precisely. It really shows how these mathematical tools aren't just theoretical. They can provide quite powerful ways to understand complex biological systems, even in agriculture.
So to wrap up for you listening, we've seen this idea of using integration, maybe something you last saw in a math class, applied very specifically. It's about tracking milk volume in dairy cows, linking it to their alfalfa feed by mathematically modeling the changing rate of production.
Yeah, it's a really concrete example. It shows that these sophisticated math tools can pop up in, well, unexpected places. The key, as this source suggests, is finding that right formulation, the math model, that truly reflects the physical process you want to measure. This lactation example is just one case study, really.
It makes you think, doesn't it? Considering this specific application, where else might powerful tools like integration be working behind the scenes, helping us measure or understand things where the rate is constantly changing in ways we maybe haven't even thought about?
It's definitely food for thought.
Thanks for joining us on this deep dive.